Good afternoon. Hi, good afternoon, everyone. So today you have a quiz. Are you able to see the quiz in Blackboard? Yes? Okay. So you can open the quiz anytime today. And then after you open it, you have to submit within 30 minutes. Okay? And make sure you are able to upload the PDF so your quiz has something in it. Okay. Yes. So you're gonna work on the problems, take pictures, convert into a PDF, and then upload in Blackboard. Okay? So no, not right now. After class. Okay. So all your quizzes are online. Okay? Okay. Yes. So yeah, why do I want you to take the quiz online? Because then we can use more class time to go over problems. Okay. Usually, if we take the quiz in class, I might give you like 10 to 15 minutes, and then after COVID, I move the quiz online. I give you 30 minutes, so you have more time. And also the 30 minutes also take into consideration you need time to take pictures and convert into PDF. That's why I give you 30 minutes instead of 15 minutes. But try your best to finish the problems within 15 minutes, okay? Because our exam is usually, 1.5 hours, right? Uh, that's why you want to, and our exam has more problems, so you want to finish them on time, so increase your speed. What happened to the other students? I know we usually have the university experience class. Is it only on Monday and Wednesday? Not Friday. No Friday, right? So.
I saw some students have
Oh, they have training before our class? Oh, okay. Because I'm a little bit concerned about our exams because I do want to give you more time on the exam. So I want to make sure like everybody can have the opportunity to come here early to take the exams. So let me ask you, are you able to come here at 12:20 to start the exam? If you cannot do it, raise your hand. Okay. Do you mind to tell me why? Do you have a class before this?
Practice is going to be,
Oh, just practice, right? Not game, right? Would you tell your coach you have an exam back there so you can come here early? How about you?
other classes.
Other class. Okay. So if you still want the extra time opportunity, you email me. We can schedule makeup exam before that day. So exam on taking the exam on Friday, it will be on Thursday before. So if you want the extra time opportunity like the others. So yes, if you want to schedule earlier, let me know. Okay, everybody? Yeah, I want to give you more time so you can do better on your exams. Okay. So today we're gonna continue to talk about session 1.5. Okay, so 1.5. Last time we talked about the transformations, right? So follow this order. Okay, when we do the transformation, make sure you follow this order. Because if you switch the order, then the transformation might change. For example, okay, if you shift left, let's say if you shift left 3 units and then we flag about the y-axis, if you change the order, then instead of shift to the left 3 units, you might shift to the right 3 units. So that's why make sure you follow this order. Okay? So first, we shift left or right. If you see the x change to x plus c, then we shift to the left. If you see x change to x minus c, shift to the right. And then reflection about the y-axis. Y-axis right here. Think about it. This is like positive x, this is negative x. So your positive x becomes negative x. So you see a minus sign in front of the x. that is refraction over the y-axis. And then reflection about the x-axis. Think about it, on top of the x-axis, your y is positive. When you flip it downstairs, it becomes negative, right? That's why if you see a negative sign in front of the y, then we have a refraction over the x-axis. And then if you see y is like whole thing multiplied by a constant, then we have vertical stretch or compress. Okay, then you say vertical stretch by a factor of c. C is this multiple. And then the last one, shift up or down. So SC, okay, see SC, then we shift up. Minus C, then we shift down. Okay, these are the order of the transformations. Make sure you can memorize them and follow the order. Okay, everybody? How about let's read together? And then the second time when you read it, you close your eyes. Okay? Read after me. 1. Shift left or right. 2. Reflect about the y-axis. 3. Reflect about the x-axis. And vertical stretch or compression, right? 4. Shift up or down. Okay, close your eyes. Read it. Close your eyes. 1. Shift. Second. Y-axis, y-axis. Third. X-axis. Or vertical stretch. 4. Yeah, shift up or down. Okay. Yes, good job. Now, last time we also did example 5, right? We look at this guy. Oh, we have a square root. Then our parent function, square root of x. Well, what are our parent functions? Remember our exercise? Yeah? X. That's x. X squared. Move your hand, everybody. X squared. This. Right? Yeah, and then x cubed. Yeah, exactly. And then square root. Only one side. Remember, only one side. Cube root. Yeah. And then reciprocal. Remember, it's like that. Okay. Good. So parent function. Square root. And yeah, the key points. Remember the key points, like at the integer point we plot them. So for square roots, there are 3 key points. Okay, they are 0, 0, 1, 1, and 4, 2. Yes, everybody. And then, okay, we look at the x. Do you see add or subtract something? Yeah, I see add 2, right? So from here, we add 2 to the x. Okay, then left plus right minus. So we shift left 2 units. That's why all these 3 key points, we shift left 3 units. You remember how we did that? And then, okay, next, this one, we check what? Reflect over the y-axis. So you check, is there a minus sign in front of the x? Yes. So from here to here, you put a minus sign in front of the x. That will be refraction over the y-axis. Okay? Yes? And that's why this point, refraction. Okay? Y is like the mirror image. This point map here, this point map here, and this point map there. Okay? So you look at the key points, and then you do the translation of the key points, and then you connect them together smoothly. Yes, you remember? Okay. So let's see, continue. And then refraction over the x-axis. Do you see a minus sign in front of the function? No, so no reflection about the x-axis. But do you see a 3 here? That's why it's vertical stretch by a factor of 3. Okay? In this case, your x stay the same. If x stay the same, but your y, you multiply by 3. Remember? A typical mistake is students multiply the x by 3 and the y by 3. No. X the same. Only multiply the y by 3. Okay. That's why we get those points. Okay, so you can compare. So you can compare the picture. It's like we stretch it to get this. And then finally, -4, shift down 4 units. So these 3 key points shift down 3 units. Sorry, 4 units. Okay. All right. So that is the attendance. So today I print out the new attendance sheet, hopefully with all your names on it. Yeah, so please sign your initial. Oh, I have an extra copy of 1.5. Who need that? Okay, so okay, he raised hand first. Okay, who raised hand first?
Rock, paper, scissors.
Rock, paper, scissors, shoot.
No, I don't necessarily need it. I left mine on my desk.
Huh?
I can just get the notes from my mine is on my desk in my door.
Oh, okay. You have to get yours. Okay, so remember next week you get the pre-now session 1.6, 2.1, and 2.2. Okay, everybody? So print out the notes before coming to class. And okay. All right. So let's continue. Okay. Now, example 6. Okay, example 6. Starting with the graph provided. Graph the function. Okay, what is the first step again? Level right. And then we look at the x. Ooh, you see x -1 is to the right. Yes, very good. So this is f of x. And so the first step is we subtract 1. Subtract 1 is shift right 1 unit. So far so good, everybody? Oh, okay. So let's put some key points. I would say there are 1, 2, 3, 4. There are 4 key points. And then we just connect them. Okay? So shift right 1 unit. Well, then this point shift right 1 unit. Do you see it's going to be at -30? You see that, everybody? So shift right 1 unit. Then we are at -30. Yes, everybody? Shift right 1 unit. Well, then this point shift right 1 unit. Then we get -2 and -1. So -2, -1. Okay. This guy shift right 1 unit. Then we get 1, 2. So 1, 2. Yeah? And then finally, this point shift to the right 1 unit. We get 4, 2. Okay, so sorry, 4, 2 right here. Okay, connect them. So we get the picture. And do you see the shape are the same? Yeah, the shapes are the same. Okay. And then, so that is the first step. What is the next step? Yeah, we found about why, yes. Yeah, very good. Then, which minus sign you want to look at? In front of everything or in front of the x? X. Do we have the minus sign in front of the x? Yes. So from here, the next step will be you add a minus sign in front of the x. Yes. This is reflects over the y-axis. So in your homework, you don't need to show your work, right? You just write down the final answer. But your quiz, bless you, your quiz and your exams, you have to write down all the steps. Okay, each step you need to give me the picture, you need to give me the formula and the translation. Right. Okay, let's see. Reflect over the y-axis. Okay, this point. Reflect over the y-axis. Do you see we get the 3? Yes. Oh, thank you. So we get the 3 right here. Okay, everybody? And then, oh, this guy. We flat over the y-axis. We got 2. Yeah. So here, get 2. Oh, I don't want to cross it, so we're gonna do this. How about this point? Boom. Right here, yeah? Okay, so let's put it down here. That point. Bless you. Minus 1, 2. How about this guy? Negative 4, 2, right? Negative 4, 2. Nice. And then we connect the points. So this is the graph. So far, no good. So the key points. And we find the mirror image across the y-axis. Okay, what is the next step? Now reflect over the x-axis. Yeah, it was y, and then now the third step, the x-axis. And then you look at the minus sign, what? In front of everything. Yes, everybody? Do we have minus sign in front of everything? Yes. Okay, good. So then the formula is, let me make it smaller. So minus f of minus x minus 1. This is reflects over the x-axis. So far, so good? Everybody? Okay. Let's see. X-axis. Wow, look at this point. We flip over the x-axis and we get to this point, right? Minus 4 and 2. Oh. So minus 4 and minus 2, I mean. Okay. And then this point, minus 1 and minus 2. Okay, here. And then, do you see this guy become 2, 1? 2, 1. And do you see the 3, 0 stays 3, 0? Mm-hmm. Yes. So then we connect them. So far, so good? Okay. What is the next step? Stretch. Yes. So we have minus 2 f of negative x minus 1. This is stretch vertically by a factor of 2. A factor of 2. Okay. Now what do we get? So this point becomes what? Will the x change? No. How will the y change? We multiply by 2. So it was negative 2. Now becomes negative 4. So right here. Yes, everybody? Okay. So right here. -4. And then this point, the x stay the same. The y multiplied by 2. You see we also get -4. Yeah, the x stay the same. The y multiplied by 2, we get -4. Okay, how about this guy? This guy, the x is 2, the y is now, it was 1, and now it's 2. Yes, we multiply by 2. So it becomes 2. Okay. How about this point? 3, 0. X is 3, y is 0. Yes, 0 multiplied by 2 is still 0. Okay, everybody? So we get 3, 0. And then we connect all the points. So this is the picture. You see, we actually stretch it. Okay. And what's the last step? Shift up and down. And here, what do we do? Up or down? Yes. So we put shift up 3 units. Okay. So this point, we shift up 3 units, we get what? -4 and -1, yes? -4 and -1. Okay. And then how about this point? It becomes -1, -1. Okay. How about this point? Yeah, 5. So 2, 5. Okay. How about that one? 3, 3. Ooh. And then we connect them together. So this is the final graph. Okay, everybody? Yes, so this is the final graph. Yes. Any questions? So each step, you need to draw the graph and you need to write down the formula and write down what transformation. Okay? And make sure you follow the order. Okay. Good. Let's continue. Even and odd functions. Okay, so graphically, a function is said to be even when its graph is symmetric with respect to the y-axis. For example, x squared. Do you see it's symmetric with respect to the y-axis? So this is an even function, okay? And you can see the power, the 2 is even, right? So even function. Symmetric with respect to the y-axis. And the function is said to be odd when its graph is symmetric with respect to the origin. Origin. An example is like x cubed. Symmetric with respect to the origin, what does that mean? Well, that means if you have a point right here, and then you draw a line through the origin, okay? And then you go to the same distance. This point is also on the graph, okay? Or you can think of this guy rotate 180 degrees. It's still on the graph, okay? So that's symmetric with respect to the origin. Okay, formal definition. A function is said to be even if f of minus x equals f of x. Oh, why is that? Think about it. This is x. Yeah? And then this is minus x. minus x is the negative side, but with the same distance to the origin. Do you see they have the same y value? Yeah, so that's even function. F of negative x equals f of x. That's the definition. And similarly, a function is odd if f of negative x equals minus f of x. So, okay, in terms of the picture, well, this is x, right? This is x, this is y. And then this guy is minus x. And this guy is minus y. Yes, yes, that's why. Oh, f of minus x is minus y is f of x. So you have the minus. It's kind of, you can move the minus sign out of the function. So far, so good? That is the formal definitions of even or odd function. Okay, example 6. Determine whether the following function is even, odd, or neither. So, yeah, we know integers are either even or odd. Okay, but for functions, we can have neither. For example, look at this guy. This is not an even function. It's not symmetric with respect to the y-axis. It's not an odd function, right? It's not symmetric with respect to the origin. So a function can be neither even nor odd. Okay, so how do we check? Well, f of minus x. Okay, so here we evaluate at negative x. That means whenever you see x in the expression, replace it with negative x. Okay, everybody? So that's why we have 4. Oh, I see an x. Replace x with negative x. So 4 negative x cubed. So far, so good. Continue, minus 7. Oh, we see the x. Replace x with negative x. So far, so good, everybody? Okay. This is how we plug in negative x. What is negative 1 cubed? Negative 1. So this is negative 4x cubed. Oh, do you see there is negative 1 here? Negative become positive 7x. Right? Oh, then you can see, well, this is not f of x, right? But is this negative f of x? Can you factor out the negative? What's left? 4x cubed. When you factor out the negative, all the signs flip, right? So when you factor out negative, oh, this negative becomes positive. This positive becomes negative. Oh, do you see this is the same as negative? This is exactly f of x. We have shown that f of minus x equals negative f of x. Then by definition, what? F is odd. Yes, everybody? So f is odd. Then we have symmetric with respect to what? Yeah, with respect to the origin. Yeah, with respect to the origin. Okay, good. Let's continue. Part B. You have to check even or odd. You always plug in negative x. Okay. So that means whenever you see x in the expression, replace it with negative x. Okay, everybody? So what do we write here? 5. Yes. 5 negative x to the 4 minus negative x square plus 1. Make sure you put the parentheses around the negative x. Okay, everybody? The parentheses is like a baby. Don't forget your baby in the mouth. Okay? Very important. So, what is negative 1 to the 4th? 1. Oh, so this is the same as x to the 4th, right? How about negative 1 to the square? Same thing. So this is the same as x squared. Oh, do you see? This is exactly g of x, right? If f of, g of negative x equals g of x, what do you say? Even. Yes, everybody? Okay. So g is even function. Then we have symmetric with respect to y-axis. Very good. Symmetric with respect to the y-axis. Good. All right. Very good. Let's keep going. H of x equals, h of negative x. We always plug in negative x. What do we get? Negative x cubed, right? A question. Oh, okay. So this one, the negative 1 squared become positive, but you still have a negative. So actually there is 1, 2, 3 negatives. So 3 negatives make it negatives. Yeah? 2 negatives make it positive. But 3 negatives still negative. How about 5? Still negative. 8 positive. Yeah, exactly. Good. So keep going. Plus negative x squared minus 1. Oh, what's this guy? Negative 1 cubed is negative. Yeah. Negative 1 squared. Positive. Oh. Is this the same as h? No. See? This is not h. Is this the same as negative h of x? No. What is negative h of x? Well, it's like we flip all the signs, right? Then we have negative x cubed minus x squared and plus 1. This is negative h of x. But are they the same? No, the first term is the same, but the last two terms are not the same. So this guy is not equal to h of x, and is not equal to negative h of x. What do we say? Neither, yes. Do you pronounce neither or neither? Neither. Oh, I forget which one is American English, which one is the British English. Neither. Oh, neither is British. Okay. So when I was in China, we learned British English. Yeah. So color is COLOUR. Okay. So neither even nor odd. Okay. So that is even or odd function. Any questions about that? No? Okay, let's continue. Let's continue on 1.6. So, yep. So next time, please print more worksheets. So like print 1 or 2 weeks ahead, because our schedule is not exact. Sometimes it's shorter, sometimes the session's longer. You see, some session is 8 pages, some session is 3 pages. So they're not always one class, one session. Not always. Okay. So please print more worksheets ahead. Okay. And right now, if you don't have the worksheets, it's okay. You can take notes on a piece of paper, and then you can cut it and tape it here. Okay. So 1.6, absolute value function. So absolute value function, we know what it looks like, right? Remember? Uh, absolute, okay, let me put it here, like absolute value of x. When we plug in x is 0, we get 0. When we plug in x is 1, we get 1. Plug in x is 2, we get 2, yes? And when we plug in x is minus 1, we get 1. Minus 2, we get 2. So this is the absolute value function. It's three shapes, right, everybody? Yes. Okay. And you can define like this. Absolute value of x. When x is greater or equal to 0, absolute value of x is x. Because x is greater or equal to 0. Okay? But when x is negative, absolute value of x is negative x. Because x is negative, negative x is positive. The absolute value is always greater or equal to 0. Everybody? Okay. And you can see from the picture, from the picture, this is y equals x. Yeah, y equals x. It passed through the origin with the slope is 1, right? Which is like 45-degree angle. Yeah, that is x. And how about y equals minus x? It goes like that. It's decreasing function, right? And also with 45-degree angle. That is why when x is greater or equal to 0, you see this piece is this piece. Yes. And when x is negative, we get minus x. See, this is minus x. That's why you take this piece of this line and then paste this piece of the line, then you get this V shape, the absolute value of x. Is that okay, everybody? Mm-hmm. Okay, keep that in mind. It's x when x is greater or equal to 0, and it's minus x when x is less than 0. Okay, now graph the function, starting from our parent function. Okay, again, what is the first step? Shift left or right?
So we x minus 3.
Yes, very good. Our formula is x minus 3. Left or right? Yes. Shift right 3 units. Okay, so what are the key points? We pick 0, 0, 1, 1, and 2, 2. Okay, everybody? Those are the key points. We have 5 key points here. Remember our square root of x, we have how many key points? Just 3, all right? But then the absolute value, we have 5. If you like, you can just take 3 key points. You can just take 0, 0, 1, 1, and negative 1. Okay, you don't need the 2, 2, and negative 2, 2. Yeah, you actually just need 3 points. Okay? All right, so shift right 3 units. So the negative 1, 1 become what? 2. So this guy become here. 2, 1. Yes? And then 0, 0 become 3, 0. Yeah? And then this guy become 4, 1. So we get here. If you just take 3 points, that's okay. Then you get this graph. Everybody good? Okay. And what's next? What's the second step? Reflect over y. Do you have a minus sign in front of x? No. You see the minus sign is in front of everything. Yes, everybody? So that would be reflection over x-axis. Exactly. Very good. So we have y equals minus absolute value of x minus 3. So this is reflect over the x-axis. Okay, x-axis. Then this 2, 1 become 2, negative 1. Yes? So 2, negative 1, right here. How about the 3, 0? Stay the same. Okay, how about the 4, 1? Yeah, very good. And then we connect them. So this is reflect over the x-axis. See? Boom. Now it's downstairs. So far, so good, everybody? Okay. What's next step? Stretch. Yes. Stretch by a factor of 2. Yes. So we have y equals minus 2 times x minus 3. Okay. So stretch vertically by a factor of 2. Okay. Tell me this point. So this point is 2, negative 1. Then what's the new point? Yes, 2, negative 2, right? The x stay the same, but the y multiplied by 2. So 2, negative 2 right here. Okay. How about this point 3, 0? Stay the same. Yes, everybody? 3, 0 stays the same. So x is the same. 0 times 2 is 0, 0. So the point stays the same. Okay. How about this point? 4, negative 2. Yes. Aha. So when we connect the points, do you see this V shape is more skinny than this V shape? Yes. So because we stretch it. Okay. What is the last step? Up or down? And in this case, what? Up. Yeah. Very good. So we shift up 4 units. Okay. Now this point map to what? Shift up 2 units. 2, 2. Yes. So this shift to 2, 2. Okay. And next one, 3, 4. 3, 4. Next one, 4, 2. So 4, 2. Aha, we connect them together. So this is the graph. This is the final graph. So far, so good? Okay. So in exam, for sure, you will have a problem like this. Your parent function could be absolute value of x, or x squared, or x cubed, or square root of x, or cube root of x. But the steps are very similar. Okay, everybody? Mm-hmm. Yeah, find the key points and show how the transformation due to the key points, and then connect the key points together smoothly. Okay, very good. Okay, let's continue. All right, solution to absolute value equations. So for real numbers a and b, an equation of the form absolute value of a equals b, with b is greater or equal to 0. We'll have solutions where a equals to b or a equals to negative b. If it's positive or negative number, you have a positive number. That's the value max. Okay. So if b is less than 0, then the equation has no solution. Because absolute value is always greater or equal to 0. Okay. So remember how do we solve equations involving absolute value? Remember the definition of absolute value. This is x, right? I don't know why it does not show it here. Okay, if x is less than 0, okay, we have x equals absolute value of x equals negative x. If absolute value of x equals to a, then x equals to a or x equals minus a. So to solve the absolute value equations, remember, isolate the absolute value first, if you can, okay? And remember to check if the solutions are possible. This is very important if the variables also occurs outside of the absolute value sign. So yeah, this is very important. Okay, those are the steps. Now let's solve examples. Okay. So if the variable is only inside the absolute value, we isolate the absolute value first. Okay, so if the variable is only inside the absolute value, then we isolate the absolute value. This is very important. Okay, so how do we isolate the absolute value? Which means we solve for the absolute value term. We want the absolute value term by itself on one side, with all the other stuff on the other side. So what do we do first? Subtract 2. Yes, everybody? We subtract 2. Subtract 2. And then what happened on the left? 6 equals 4 times absolute value of x minus 2. Yes, everybody? What do we do next? Divided by 4. Yeah, divided by 4. What is 6 divided by 4? What's the common factor? 2. Yeah, 3 over 2 equals absolute value of x minus 2. Okay, everybody? So if you have, okay, so like this is like first step. Okay, after you isolate the absolute value. So remember, absolute value of x equals to a. That means x equals to a or x equals minus a. So in this case, you can think of this whole thing was like x. This is like the a. So the whole thing, absolute value, the whole thing equals 3 half. That means this whole thing equals 3 half or negative 3 half. Okay? So you put x minus 2 equals 3 half or x minus 2 equals negative 3 half. This is how we break the absolute value. Is that okay, everybody? Yes, so use this. Yeah. This even though it has a negative 2, it's okay. You can think of this as like the whole thing. Okay, the whole thing equals to 3 half or negative 3 half. Then you solve for x. Okay, so break it and then solve for x. Okay. All right, what do? We add 2 on both sides, right? So we get x equals, what does this guy add to? Is it 5 over 2? 7 over 2, right? Because 2 equals 4 over 2. Okay. Yeah, please take notes. Where's your notebook? Take notes. It's very important to. Oh, you don't have the note. Do you have the notebook? Oh, okay. Yeah. So right now, it's good to take notes because when you have questions, you can put a question mark next to it. Then you can ask me later, right? Or you can ask me now. Okay. So 2 is 4 over 2. That's why 3 plus 4 is 7 over 2. Okay. And then this guy, when we add 2 on both sides, what do we get? 1/2. So this is the answer. So far, so good, everybody? Yes. So we get 2 solutions, 7/2 and 1/2. Okay, everybody? Mm-hmm. Yes. Okay, so this is what happens if we have the variable is inside the absolute value. We isolate it, and then we break it. Okay, so we break it, you set it equal to plus or minus a, and then you solve for x. Good. Example 3. For the formula f of x equals absolute value of 4x plus 1. Oh, let me make sure. Am I unmute? Okay. Yes. Find the values of x such that f of x equals 0. So we call such x the zeros of f. So the zeros are the x values such that the f of x is 0. The zeros are not 0. You know what I'm saying? The 0 is a name. It's an x value such that f of x equals to 0. But the zeros might not be just 0. It could be non-zero numbers. So be careful. They are the x-intercepts of f. Okay. Oh, by the way, I need to apologize because our class ends at 1:57, and on Monday I kind of forget that and let you go at 1:50. So our class ends at 1:57. So I usually plan to let you go early. Maybe we end at 1:55. You can leave like 2 minutes early, but I should not let you go at 1:50. Okay, so remind me if so in the future I forget that. So okay. Hey, don't tell me you want to leave early at 1:50. Okay, let's continue. So we want to find x such that absolute value of 4x plus 1 minus 7 equals 0. Okay, everybody? How do we solve for it? We isolate the absolute value, right? Yes, we isolate the absolute value. And then what happens? How do we break it? This thing equals 7, or this thing equals -7. Exactly. This is how we break it. So this thing 4x plus 1 equals 7, or this thing 4x plus 1 equals to -7. How do we solve for x? Subtract 1. Then 4x equals 6, and then divided by 4. Ooh, what is x? 3/2. Yes, very good. Right, everybody? How about on the other side? Subtract 1. 4x equals -8. And then divided by 4. So x equals -2. Oh. So we have 2 zeros. You see? The 0 is not 0. The 0 is 3/2 and -2. Okay, everybody? So these are the zeros of the functions, or the x-intercept, or you can say it's the root of the function. Okay, everybody? Let's increase difficulties. Look at example 4. Example 4, you see now the variable is inside the absolute value and outside the absolute value. So we cannot use the thing we learned. We cannot isolate it and then solve it. No. So what do we do? So in this problem, you see x is inside the absolute value and outside. Okay? So in this case, what do we do? So this is how we do it. put a vertical line in between. Okay? On your left, you replace absolute value of x squared minus 3x by x squared minus 3x. On the right side, we replace the absolute value of x squared minus 3x by negative of whatever inside, so x squared minus 3x. Okay, so now if you have x's inside and outside of the absolute value, you kind of break it. The first on your left, you simply just like ignore the absolute value. Okay, on the right, you replace with minus of the whole thing. Okay, so and let's continue. So on your left, it's kind of you get rid of the absolute value, so just ignore it. Then you have x squared minus 3x equals minus 4x plus 6. Is that okay, everybody? On your left, you simply just ignore the absolute value, so take it out, okay? And solve for x. How do we solve for x? This is polynomial equations, right? You move all the terms on one side and you factor. Yes, everybody? Okay, so shall we move all the terms to the left or move all the terms to the right? Move to the left. Then we need to add 4x on both sides. Yes. And can I also subtract 6 in the same step? Is that okay, everybody? Then what is on the left? How many x? 1x. And then the constant term is negative 6. And then the right hand side is 0. Okay, everybody? So this is how we do it. Now, can we factor? How do you factor it?
It would be x minus 2 x plus 3.
Very good. Okay. Yes. Are you guys familiar with factoring? If you need some factoring exercise, please come see me. I can give you more factoring exercise. Okay. Yes. So negative 6, the factor is 1, 6, or 2, 3. And one of them is positive, one of them is negative. But you see the 3x. So we multiply the 3x. Here multiply, we get negative 2x. We add them, we get positive x. So that's why this is how we factor it. Is that okay, everybody? Mm-hmm. Yes. Okay, if you have a product of two factors equal to 0, then we have the first factor is 0 or the second factor is 0. So yeah. Okay, so either one of the factor equals 0. Okay, solve for x. Then x equals what? 2 or x equals negative 3. Yes, everybody? Okay, so this is on the left. Now on the right, replace the absolute value by negative of, boom, whatever inside the absolute value. So negative x squared minus 3x equals negative 4x plus 6. So far, so good, everybody? Yes? Okay. I would say move this to this side. Yeah, because then the minus will become plus. Do you agree? Yeah. So we add x squared and subtract 3x. So we add x squared and subtract 3x, right? X squared minus 3x. Yeah. Then these guys gone. We get 0 equals. Let's reorder it. We have x squared and then what? Minus how many x? 7x plus 6. Is that okay, everybody? Yes. So, yeah, we want to simplify so that the leading coefficient is constant. That's why we move things to the right. If you move things from the right to the left, you also need to cross-side multiply by -1 to make the leading coefficient constant. It's easier to factor. All right. How can we factor it? Yeah, -6 and -1. Yes, everybody? Yeah, everybody okay with this factoring? Yes. Then we have what? X minus 6 equals 0 or x minus 1 equals 0. Then x equals 6 or x equals 1. Good. We have 4 solutions, but be careful. We are not done. Okay? So we're not done. What we need to do is we need to check. Okay, so for the previous method, if you only have the variable inside the absolute value x and you isolate it and then you to break the absolute value this way, you don't need to check your answers. But if you have x inside and outside of the absolute value and this is how you do it, you need to check your answers. Because some answer might not be the solution to the equation. You have to check. Is that clear, everybody? So yes, let's check. X equals to 2. So x equals 2. Plug in. We plug in. We get what? 2 squared minus 3 times 2. Is it equal to -4 times 2 plus 6? Let's see. 2 squared is what? 4 minus 6 is -2, right? Absolute value of -2. Is it equal to 4 times 2 is -8 plus 2 plus 6. -2. What's absolute value of -2? 2. Is 2 equal to -2? No! See? This is not a solution. That's why we need to check. Because the answer might not be a solution. Okay, we check -3. So, plug in the formula, we get -3 parentheses squared minus 3 times -3. Is it equal to -4 times -3 plus 6? What is -3 squared? 9. -3 times -3. 9 plus 9. 18. Yes? Yeah, is it 18 equals to -4 times -3? 12 plus 6. 18. Is it 18 equals to 18? Yes. So this is a solution. Okay? I do the same thing here. X equals 6. Okay. So 6 squared minus 3 times 6. Is it equal to -4 times 6 plus 6? What is 6 squared? 36. 3 times 6? 18. 36 minus 18 is 36 minus 18 is 18. Yes? Everybody? Okay. 4 times 6. 24. -24 plus 6. -18. So is 18 equal to -18? No, this is not a solution. Okay, almost there. Plugging 1. 1 squared minus 3 times 1. Is it equal to -4 times 1 plus 6? What's 1 minus 3? -2. Absolute value is 2. How about on your right hand side? 6 minus 4. 2. Is it equal? Yes. Good. X plus 1 is the solution. So we have two solutions. They are x equals -3 and x equals 1. Any questions? So when you see x is in the inside the absolute value and outside, this is how you do it. Okay? You either ignore the absolute value or you replace by negative of that. So you have to check your answers. Questions? Oh, okay. So backward saying 5x is a verb. So if we want to multiply, we need to put an x. Oh, yes, yes. Try? Yes, try again. See you on Wednesday. Have a nice long weekend. Oh, so you're submit another one? Okay, okay, I'm fine. Thank you. Oh, I'm able to save as a PDF? Oh, okay, okay. Okay, yeah. So you practice, right? Oh, oh, yeah. See? You don't have practice? Sorry. Oh! Oh, they think copy and paste. They use copy.
Sorry.
Can you use one of those video techniques? Yeah. Yeah. Or do you have an extension of the keyboard? Maybe you want to do it over one. Yeah, so yeah. Yeah, the Mobius, yeah, sometimes we use that, especially for closed interval, really graphics. Open interval, practice. Closed interval, stuff. Yeah. Yeah. So either use an internet computer or by a keyboard. Yeah, USB keyboard. Hi, I just want to like options like this, we want to set it as like x equals this or that, or it's like x equals -3. Oh, it's over. Or yeah, and also like if I'm not for like fasting all the time, then just say like it does longer, but for the
Hey, Corey.
yeah, okay, yeah, yeah, I see. Okay, yeah, and that's a little more handy. And then if I can't turn in like the chemistry, would you in my yeah, that's what I did. Okay, yeah, and it has to be if you exceed that limit, then you open the thing right away. But yes, two attempts for this. It should be just one. Okay. The second attempt, I leave it there in case you need to. Yeah, sometimes if you fail to do the conversion, if it's the conversion, oh yeah, then you can start the attempt right away. So it's okay, but just very solid. Right. Okay. Hi. Hi. Oh, Oh, hi.
Hello.
Hello.